Hello guys, welcome to Big Book. Today we are going to discuss in these slides a new topic, a lab practical, that is estimation of the amount of sodium hydroxide using oxalic acid. It's a titration method. Uh, Before getting into these slides in detail, we will just go through the definition of titration. Here it's a acid base reaction. So according to that, the titration has been defined. The neutralization reaction between an acid and a base can be very useful. In an acidic solution of known concentration is added to a basic solution of unknown concentration until the solution is exactly neutralized. It is possible to calculate the exact concentration of the unknown solution. It is possible to do this because at the exact point where the solution is neutralized, stoichiometrically equivalent mole amounts of acid and base have reacted with each other. As per this definition, acid and the base are the two substances or the reactants, we can call it as the reactants, which are going to take part in the titration method. Here it is titration method because one substance out of the two, or one reactant out of the two reactants, is going to stay as the unknown by its mass and also its normality. Also the second substance, it is going to be known to be as the standard substance. So it is going to so we are going to have the value of its normality and also of its mass. So here, with the help of this normality of one of the substance, the other substance normality can be estimated. So here, as per this definition, it is like it is explaining like it is the acid, which is one of the standard form, and the base is the one where we are going to consider it to be as the unknown and has to be estimated. But it can be also a vice versa in the titration. So with the help of the standard acidic base, we can estimate the a unknown acid also. So here at a particular point, the neutralization of the both the acid and the base is going to take place. So the pH is going to get neutralized. So at this particular point, the value of the unknown can be estimated. Value in the sense the normality we can estimate, and further we can estimate the mass of the substance. So here this is what the explanation. So we are going to discuss the same thing with the help of the slides, but as with respect to the topic, that is the estimation of the amount of the sodium hydroxide using standard oxalic acid. So this is the principle. So in this slide we discuss the principle. Oxalic acid is the weak organic dicarboxylic acid, and sodium hydroxide is a strong monoacetic base. The reaction between them is acid-base neutralization reaction, where a known volume of given sodium hydroxide is neutralized with oxalic acid to produce the soluble sodium oxalate in solution. This solution is then can be concentrated and crystallized to produce sodium oxalate salt. So here as per the topic or the title of the experiment, sodium hydroxide is remained to be as the unknown substance or the reactant, where it will be neutralized with oxalic acid, which will be the standard substance. So here we know the normality of this particular oxalic acid to produce, that is the end product after the titration, which we are going to get in the end of the experiment. So it can crystallize. So this is the further explanation. The equation is like this. oxalic acid solution plus aqueous solution of sodium hydroxide. Sodium oxalate will be formed and water molecule, the liquid, will be formed. Here this is the aqueous form. So last line is regarding the indicator. Indicator is the one which is going to show the end point, that is the perfect neutralization of this acid and base. So when we are going to use the phenolphthalein in the base medium, so here as we are going to taking the sodium hydroxide as the base medium, if you are going to use here if you are going to add the 2 drops of the phenolphthalein or any amount of the phenolphthalein, the solution of the base or the basic solution is going to turn to pink in color. If you add this same phenolphthalein in the acid medium, it is not going to give any of the color, but in the base it is going to give the pink in color. So coming to the procedure, in this we are going to take exactly 25 centimeter cube of the cc of the given sodium hydroxide, that is the 25 ml of the given sodium hydroxide solution is pipetted out into a clean conical flask. Then we are going to add 2 drops of phenolphthalein indicator. Then the solution turns pink. So here the solution turns pink. Then we are going to take this conical flask of sodium hydroxide solution of known volume but not the normality. So here we are going to, which is again with the phenolphthalein indicator, will be subjected with the 0.1 normality oxalic acid. So here we know both the normality and also the volume, which is going to run down now into the conical flask with the strong base of sodium hydroxide and the phenolphthalein indicator. So here oxalic acid is added to the solution, sodium hydroxide solution in the flask from a burette till the color of the solution disappears permanently. The pink color is going to disappear at a particular point. So we have to be very careful while running down the oxalic acid. It is to see that the color, pink color of the sodium hydroxide has to disappear with a mere addition of the oxalic acid. So sometimes what will happen while running down the oxalic acid or the solution from the burette into the conical flask, we will forget to look that the change in the indicator's color is going to happen, but we will overflow the volume from the burette. So here further, after this, as the color disappears, we are going to take the readings of the burette which is having oxalic acid. The volume will be noted. So here like this, we are going to repeat the trials up to 3 times. So here the first can give some error, so we can take the second trial also and the third trial also. So as per this procedure, complete procedure, we are going to repeat this procedure 3 times, first time, second time, and 3 times. So further we are going to tabulate those results. Here what you are seeing, this is the tabulation of the burette readings. This will be the first trial, second trial, and the third trial. So here first initial burette reading of the actual oxalic acid and the final burette reading of the oxalic acid. Initial and final reading in the sense, before to starting the experiment, before to subjecting the NaOH in the conical flask with the indicator to the oxalic acid, we have to make a note of what the volume of the volume of the oxalic acid in the burette, and we are going to mention that reading in the initial column. And further here we are going to, after the addition and the change in the color of the indicator, whatever the rundown of the volume of the oxalic acid, that will be the final burette reading. So further, after this, for the second trial also we are going to take the same in the same manner the readings for both initial and final, and third also initial and final. So here we are going to take second and the third into the consideration. Sometimes in the labs or in the practicals we will take out of these three, two readings. In some labs they will take second and third reading itself, but in our experiments, in our labs, we have taken first, second and third, and we have considered the two readings out of the first, second and third which are quite near, so that we can so that we are considering that to be as the mere difference which is going to create the neutralization, that is it is going to create the difference in the color of the indicator. So it is going to show the complete neutralization of the acid and the base. So here, after considering two trial values, that is those values will be considered here in the final volume of acid rundown, that is the subtraction of initial burette reading with the final burette reading. Whatever the volume or the value we get, that we are going to consider. So here, during this time we are going to consider two trials, and these two trials mean will be taken, and that will be the x here, because we have mentioned it to be as the x, as we are having the empty values and no values, so we are going to consider it to be as the x. So here further, after getting this volume rundown, we are going to take a equation which is called it to be as the normality equation, which is going to be like this, that is NV is equal to NV. Here at the left NV, we are going to mention 1 as the subscript, N1 V1, and at the right N2 V2, that is the 2 as the subscript for this. So 1 and the 2 represents the two different substances or the two different reactants in the of the titration. So here one is NaOH and second is the oxalic acid. NaOH is the substance which has to be estimated with the help of the oxalic acid. So here oxalic acid is going to have both the normality and the volume. Here if you say oxalic acid's normality is N by 10, that is 0.1 normality, and the volume is the one which will be the x. So here the product here, it is going to be the whatever the volume here we get, that will be the x, that will be producted with the normality. Now here if you are going to consider the sodium hydroxide, we don't know the normality of the sodium hydroxide, so we know only the volume, that is the 25. So here 25 into N1 is equal to x into 0.1. So therefore it is going to be N1 is equal to x into 0.1 divided by 25. So if you are going to substitute a value here, that is at the x, you are going to get the normality of NaOH. So this normality of the NaOH further has to be multiplied with the gram equivalent weight of the substance which has to be estimated. So in the sense, we are going to consider the equivalent weight of sodium hydroxide here, which is again equal to the molecular weight of the sodium hydroxide, that is the 40. So this molecular weight of the sodium hydroxide is considered to be as the gram equivalent weight. So it will be multiplied with the normality of the sodium hydroxide. So whatever the result we get, that will be the mass per decimeter cube of the NaOH. So this is how the mass or the estimation of the sodium hydroxide will be done with the help of the oxalic acid, that too by identifying the normality in the prior steps. So here in the same manner as we have done the calculation for the mass per decimeter cube of NaOH, we can do the calculation for the mass in 250 centimeter cube. So this is different from the decimeter cube. So n into 40 into 250 divided by 1000. Here we have mentioned it to be as the 250 and the 1000 as the new values added. So here 250 into 1000, in the sense here we are going to divide this value, whatever the value we got into here, n1 into 40, that will be divided by 4 parts. So as we have mentioned that decimeter cube here, it is equivalent to 1 liter of the volume. If you are going to consider 250 centimeter cube, that will be the 1/4 of the volume. So here this value will be further produced or multiplied by 250 and divided by 1000. So here when you are going to do this divided by the 1000, you can see here n1 into 40 divided by 4. So n1 into 10 grams. So here you can make and understand the things which are very different from line to the line or equation to equation here. So this is how we are going to estimate a sodium hydroxide using standard oxalic acid. So here this is the calculation part. So I hope I have given a very brief and complete detail of the experiment. If you have any queries or the doubts, or if you can't able to follow up with the experiment, you can write down in the comments. And also I request you guys to help me with the topics which you want to hear from us. And also I ask you guys to encourage me to do better with the different topics, and also help me out by giving the feedbacks. Thank you for watching these slides on Big Book.